So first thing we need to figure out for naming is whether a compound is covalent or ionic. And now we've talked about these two before, and this is the first decision you need to make from a very large tree to figure out how to name a particular compound. So what I want to go through quickly is just a quick review of the differences between the two types of compounds. So first I've got ionic compounds here. So these are held together by electrostatic charges. Because they have to be arranged in a very particular way to minimize the repulsions and to maximize the attractions, they have a very regular array that extends throughout the entire actual chunk of the stuff. Now, because of that, everything's sort of connected to everything else. So these things didn't have any discrete molecular subunits, no molecules. And as such, they are described with an empirical formula. Now, because the electrostatic interactions holding all of these charged particles together are quite strong, it's pretty hard to break them, so they've got high melting and high boiling points. They tend to be, pretty much are always solids at room temperature. Now, they are also brittle, and they are poor conductors of heat and electricity, and they are often, but not always, and stay tuned for this exception, a metal-non-metal pairing. So it's critical that you be able to look at a periodic table and determine, what side is metal, what side is non-metals. And if you have a pairing of one of each, it's an ionic compound. The other type of compound that we discussed were covalent or molecular compounds. These are held together by electron pair sharing, not actual electrostatic attractions and repulsions. Now, these do have distinct subunits that we call molecules that describe the smallest number of atoms that are actually held together by this electron sharing. So we describe them with a molecular formula, and not just a ratio, but the actual numbers. Now, the interactions that hold a molecule together internally are quite strong. They are about as strong as the ionic interactions, but there's hardly interactions between one particular molecule and any of its neighbors. And because of that, they tend, some can be solids, but they can also be liquids or gases at room temperature, implying that those interactions are quite weak. And generally, these compounds arise from the combination of two nonmetallic elements. Again, this is all review. All right, so the other thing you need to know is there are some elements whose ions charge you can predict based on where they are on the periodic table, and those were the elements that are either to the far left or to the far right. And I'm going to call these, so if you can see a broad trend here, metallic elements, so that is those to the left of this red stair step here, they form positive ions, also called cations. So the overall broad chemistry of metallic elements is dominated by the fact that they tend to lose or give away electrons. The non-metallic elements, these guys over here, when they form ions, you'll see here they form negative or anions. So broadly speaking, the chemistry of non-metallic elements is dominated by their tendency to pick up or gain electrons. All right, so for those elements whose charge is predictable, whether they're on the metallic side or on the non-metallic side, I want to call these type 1 ions. And if you look more carefully here, you can kind of see that all of these in the first column tend to form +1 ions, +2 for this. On the other side, the pattern has just one more little wrinkle to it. The noble gases, and if you'll recall, they have these magic numbers of electrons. They are perfectly happy the way they are. So they don't give them away, they don't take them, they actually don't do much of anything. So they tend not to form ions. But here you get, so the first group in after that, the halogens, as these are called, fluorine, chlorine, bromine, and iodine, tend to form -1 ions. These guys -2, these guys -3. The ones here in the middle are not so nice, or we'll say not so predictable. A lot of them, so they are still metallic elements. so they will form positive ions, or cations as we call them. But many of them can form more than one charge. And the charges are not, +7 or +10, something like that, what you'd expect from what column they're in. Picking up or losing a couple of electrons, picking up a couple of electrons is not that big of a deal. To get their magic number, these would have to pick up or lose like 7 or 8 or something like that. And that becomes energetically unfeasible. But typically they'll form, a lot of these elements will have 2 charges, and they're usually between +1 and +4. And these, you just kind of have to, there's a way that you can figure these out from the name. That's coming up. The other thing to note is that hidden within this range, there are a small number of still type 1 ions, notably silver, which is reliably +1, cadmium, which is reliably +2, and zinc, which is also reliably +2. The other ones tend to form somewhere between +1 and +4 elements, or charges, I should say. And just to review some names, because you'll hear these a lot. That first group is referred to as the alkali metals. Second group, alkaline earths. Third group, this group right here with oxygen, these are called the chalcogens. The group with fluorine on the top, chlorine, bromine, and iodine and such, they are the halogens. And again, the metals in here are referred to as the transition metals, the ones in the middle. Right. We also talked, and I'll review briefly why those elements form the charges that they do. And it's simply because they are within 1 or 2 electrons of the magic number that the noble gases have. If they have 1 or 2 more, like our friends sodium and magnesium here, they'll lose 1 or 2 to mimic the number that magnesium has, in this case 10. If they are a few short, they can pick up 1 or 2 to get that 10, which is what fluorine and oxygen do. And again, once you get beyond picking up, or losing 2 or 3, energetically that becomes a bit of a problem, which is why the charges of the transition metals are a little less predictable.